All right, well, we're at 101, so we have a really great lineup. Thank you all for being here today at the RIEEE December 2022 webinar. The RIEEE webinar series provides a platform really for whatever we think as a group, inclusive of everyone who attends, is important. But we really like to use it as a platform to explore possible connections, highlight strengths that we have here in sustainability research areas at Appalachian State, and including our community, local, national, and sometimes global partners. So it's really a time where we can learn about research that falls into kind of the sweet spot of where we think we can make a difference in particular strategic sustainability areas. So this particular session is going to highlight research projects and local efforts to address critical questions around food production and sustainable food systems in ways that minimize environmental impacts, contribute to resilient communities and resilient economies as part of that, and are regenerative and collaborative. So with that, I'm going to pass it off to Grace Plummer, who, as the RIEEE Research Development and Program Manager, has done all the work to assemble this great panel and our fantastic speakers. And she will be introducing our three great speakers, each of whom will have around 12 to 15 minutes and may be able to answer some questions as well. So thank you, everyone, for being here. And Grace, I will pass it to you.
Thank you, Christine. And thank you all for joining today, and speakers for giving us a bit of your valuable time at the end of the semester here. So our plan for today, we have actually 4 speakers, but they'll be presenting 3 presentations. And they'll have about 12 to 15 minutes apiece. If there's a little bit of time at the end, we'll have some quick Q&A while we transition between speakers, but there will be some time at the end to have discussion, and some of the speakers can stay on past the hour. If there's a vibrant discussion going, you're welcome to stay on for that if you're able to. And just a reminder that we're recording this and we process and then upload to our YouTube channel, so they're available to review later. You can also share them if there's someone in your networks that you think might be interested. And to that point, if ever you receive information about one of these webinars and you think it would be of interest to someone within the university who may not have seen it, or outside of the university, feel free to pass it along. Okay, so we also have a form that we'll share. Christine might link it in the chat now, but we'll send it again at the end for those of you that might be interested in doing something as a follow-up with this, if you'll use that form as a way to kind of help us figure out if and how we might follow up most effectively. Okay, so our presenters today are, the first presentation will be Jeremy Ferrell and Andrew Windham. They are both faculty in STBE and assistant chairs, I noticed, as I was putting the bios together. Jeremy's research and teaching focuses on renewable energy innovations that serve rural, under-resourced populations, particularly in smallholder agricultural applications. Andrew is his research and teaching focuses on integrated building systems, building energy modeling, and controlled environment agriculture. Our second presentation will be from Mike Hambourger. He's an associate professor in AppState's Chemistry and Fermentation Sciences department. His research interests focus on anaerobic digestion as an agricultural waste remediation solution, and among other photo and electrochemistry approaches to energy conversions. The third is from Liz Whiteman, who is executive director of Blue Ridge Women in Agriculture, where she directs programming and staff in support of rebuilding the local food economy in the high country region. Liz studied political science, and her passion for regenerative agriculture has taken her across the US and beyond, including a 5-year stint in DC, influencing federal farm policy at a national nonprofit. So without further ado, we'll turn it over to Jeremy and Andrew, and they'll present greenhouse performance analysis at the Blackburn farm.
Okay. Everybody see that? All right. Well, thanks, everybody. Good afternoon. I'm Jeremy, and Andrew and I are going to kind of tag team this. I'm going to drive here, but we're going to tag team this. And really, we're going to talk about these greenhouses out at the Blackburn farm. And I'm going to give you a little background on where we've come from and where we are going and where we are now. So we're both in sustainable technology in the built environment. So this is a picture of the farm. The one on the left is the series, what we call the high performance greenhouse. And the one on the right is a typical high tunnel, 2 layers of plastic. And they're really about the same size. They're both about 1,500 square feet. So it's made for a really nice potential long-term research study here. So I'll set it up a little bit. Let's see. With a quick problem statement. So there are some factors that are converging to push growers to adopt protective environments, namely greenhouses. And they are declining water availability, erratic temperature, and increased pest pressure. And so we're really seeing a dramatic increase in crops under glass and plastic in the last few decades. And it's really a broader movement that speaks to this idea of controlled environment agriculture that really encompasses a variety of technologies and takes a variety of systems, and it takes a technology-based approach to farming. And this is everything from vertical farming indoors to the picture on the right is a picture of Against the Grain Farm. They're one of our partners that we've been lucky enough to work with. They're an amazing farm operation in our community. And they controlled environment agriculture can be from low to high tech, but you can see even on the right there, there's LED lighting, there's fans, there's controls, there's a germination chamber. So there's different levels of CAE. And this is significant in both the market and in North Carolina. There's a big growth in production under plastic and glass, as I mentioned. It's about almost 10% and compounded. And then the lighting has really taken off due to LED improvements, and it's about 24.5% compounded annual growth. And agriculture is a big part of the state's economy, big in terms of jobs and total revenue. So real quick, we basically are doing a series greenhouse and got into this because of a really amazing alumni named Christian Haupt, and he worked with our Nexus program and then got a job based on the work that he was involved with, and moved out to Colorado and got a job with Ceres and has done really well. And we basically said, hey, if you get this job at Ceres, we're going to try to get one here. And we put together an awesome team of unit and different units around campus to do this. I love this photo. This is from our dear friend Marie Freeman, who we miss, but she flew a drone back in fall of 2020. You can see the site here. This is at the Blackburn farm, so the old historic 1890s farmhouse here, the existing high tunnel atlas, and then the Ceres greenhouse under construction. So I've got a few construction photos that I'm going to go through pretty quickly to give you an idea. And this is just to show you kind of where we are. We have an industry partner, and then we have lots of campus partners, which have all been contributors financially as well. So we've got a really great multidisciplinary team and multiple units really across campus. And for those of you all that may not be aware, the Sustainable Development Agroecology Program uses the farm in their practicums, and the food that is grown there is actually purchased by university dining. So we have a nice circular economy there, where dining, and here are some of the chefs that came out, and they put in orders for specific things they're interested in, but we have that really great connection here. So we're going to talk a little bit about this greenhouse. It is a high performance greenhouse. It is more expensive than the traditional high tunnel, but we're going to be looking at how it performs here. So there's a few technologies involved. It's well insulated. That's maybe not a novel technology, but it has this unique heating and cooling system called the GAT, or ground to air heat transfer. And it basically uses solar energy, and it transfers that energy into the ground. There's a fan that blows air from the greenhouse down through a series of heat exchangers in the ground. And in the heating mode, takes cool air in, and warmer air comes out of the GAT. It also operates in the same direction, but it can cool the greenhouse. So on a hot day, it can take that warm air, move it through the heat exchange tubing underground, and cool the greenhouse. So it basically operates like a heat pump, but uses fans instead of a compression cycle. And just some of the impact here, the closed loop food production research initiatives. I mentioned the longitudinal study, the side-by-side, using it in classes, looking at this GAT system that's pretty unique, looking overall at energy and food production and demonstrating to the community some different technologies for year-round and season extension. So little background, some of the construction, this did happen basically right when COVID hit, and it caused a lot of delays. And when we were able to actually get out there, we discovered other supply chain delays and things like that. But we pushed through and were able to do the majority of the construction in 2020 and 2021. These are insulated concrete foundation, and the underground heat exchange piping is in this footprint. We actually were able to subcontract the construction of the GAT to ourselves. And so Andrew and I and others led the construction of this, along with Chip Hope and Todd Rudisell at the farm. And so we were able to build this. It uses common materials like a 4-inch corrugated drain pipe and 18-inch culvert pipe that you can buy almost anywhere as the heat exchange material. So it's not real complicated to build, but it did involve lots of earth moving. And lots of students were very eager to get out and do things back at that time when we were all online all the time. And so we were happily masked, working outside, using our hands. And we installed these sensors in the tubing underground. This is a picture of Lainey's sink here in the bottom left. She did her master's thesis on this project. And so we were running pull wires through it so we could come back and actually pull temperature and relative humidity sensors underground, which is pretty unique. This is the first of the, from what I know of, in a series greenhouse that has this level of instrumentation. Some more pictures, lots of earth moving. And this is what it looked like before they put the insulated metal panels on. And getting kind of toward the completion, final site work and grading. And we came back and did some more sensor work. We had students doing soldering, putting these in the tubes underground, like I mentioned. Dr. Reichel here, Brian Reichel, I think, is on the call. This is Brian Reichel here showing off his handiwork with the electrical monitoring. So we have electrical monitoring on all these different circuits as well, so we can look at electrical use and energy use. And that brings us really up to kind of where we are now, and I'll show you some results here of where we are. But we're still working on incorporating all the underground sensors, doing some sensor validation based on Lainey's master's thesis. I think we have an article that can be published. We're looking at some data management analysis and continuing this comparative study. And if people are interested in this, I'm happy to share links with these, but we do have data feeds that are public access that people can look at. All of the agroecology students, you have this on their phone now. Chip Hope has it on his phone. So we can see what's the temperature in the greenhouse, and do I need to go out there and do anything? But I'm happy to share that if anybody's interested. And I'll show a few charts here. I actually had fun putting these together, anticipating this meeting. And so this is actually over the past couple of days. And this is some time series data with outside temperature. We dipped it below freezing a little bit the last 2 nights. The temperature of the Atlas, that's the high tunnel, the hoop house with 2 layers of sheet plastic, the temperature of the series, and then the dotted line is to show you where freezing is. And you can see some trends here. Well, it got down below freezing on the night of December 1st. And the series greenhouse got down into the low 50s. The Atlas greenhouse got down a little bit lower. And so you can see this range that's happening here. The high performance greenhouse is getting down into the maybe the 50s Fahrenheit and staying below 80. That's a pretty good tolerance in terms of ability to grow a wide variety of plants there from a temperature standpoint. They just installed a wood boiler, so you can also see just from the temperature that the outside temperature, this blue line here dropping, and the wood boiler maintaining some of the heat in the Atlas. And then probably the fire went out somewhere in the middle of the night and the temperature keeps dropping. So an idea of kind of general temperature performance over the past few days with this chart. We've got a couple others, and then if anybody has specific questions, we can look at those. Here's another, this is some of the effect of the GAT on the series temperature. So in this chart, we're just looking at the series greenhouse. Remember, the GAT's taking air from the greenhouse, circulating it through that underground heat exchange, and then either operating in cooling mode or in heating mode. In the cooling mode, we have the outlet temperature, the orange line, higher than this yellow temperature, the inlet. And this is during the day as we get solar radiation in the day, it drives up temperature. The GAT is actually providing a cooling effect and keeping the internal temperature below 80 degrees. And then at night, the fan blowing in the same direction is operating in heating mode here, where the outlet is higher than the inlet. So you can see the heating happening at night, preventing dramatic cooling from the building, and the cooling happening on sunny days. So we can see the effect of the GAT here. This is the last few days. And let's see, maybe a couple more charts here. Hourly temperatures, I looked at temperatures over the month of November. November was fairly mild other than a week of cold weather before Thanksgiving. But you can see the trend here, the temperatures throughout the night and day averaged over the whole entire month. And the series really maintains a pretty tight band, between upper 50s and maybe mid 70s. So it's a pretty ideal environment to grow lots of different crops. The Atlas, the high tunnel, has more variation, as you would imagine, because it's not as well insulated. And then we also have the ability to look at things like solar radiation and PAR light. PAR is the photosynthetic active radiation. The picture on the left just shows the difference in the photosynthetic active radiation, which is pretty much the visible spectrum, about 400 to 700 nanometers. And this is interesting because it shows you that the selective polycarbonate glazing, which is a kind of a rigid plastic that they use in greenhouses, that it actually has been selected to have better PAR light. You see that here, even though the total area of the Atlas is much larger. So on the left, it shows that series selected a glazing material that was improves PAR transmission. And then on the right, this is total radiation. So this is about 300 to 2,500 nanometers, includes infrared. And so you can see that the Atlas here actually does a little bit better job allowing total radiation in compared to the series. And you can also see the attenuation of the glazing. Look at the difference here between outside measurements and inside. So we're losing a lot, but that's sort of the trade-off that we pay when we have this glazing that provides some insulation as well. So I think coming up here and I'm running out of time. Here's where we are. We've done a great job internally. We've had lots of support, including from RIEEE on this project, from the Renewable Energy Initiative to food services to get the greenhouse built, and then probably another 25K or so to instrument it. And then our department has provided some graduate assistantships, and we've gone for some external grants, but we haven't landed one yet. So we're looking to work with our partners at RIEEE and other places to kind of build out a better external proposal. I think we're in better shape now with more of this data and some analysis being done. And with that, thank you all. And Andrew, if you want to chime in here with a couple points, I know you had a few things, then we'll move on to some questions.
Yeah, I'll just kind of reinforce that we have a really great opportunity for a really nice longitudinal study on how this thing performs, and not only in terms of the environmental control, really trying to optimize that for potential crops and things like that, but to also kind of complement with the thermal and electrical energy flows and optimizing the actual design of systems. And so there's a lot of great opportunity with this facility now, and so we're kind of at the starting point of a lot of potential discovery here. So it's kind of exciting.
Thank you, Jeremy and Andrew. It's really interesting. I went ahead and stopped your screen share to let Mike go ahead and cue his up. And while Mike's doing that, if you want to take a quick question, if someone has one.
I
Mikey?
wonder if no one has a question. I wanted to invite Nicholas to share his comment. Maybe that could prompt a question about whether this is possible or interactive sharing of the data are on people's radar.
Yeah, would you like me to restate what I said?
Sure, that'd be great. Thank you.
I was, yeah, I was echoing you, Christine, saying that this is so cool to see these nearly real-time data and wondering if they are either the data from this project are displayed in any AppState buildings to generate student conversations and show and enable us to have those kinds of conversations about what's going on. And then alternatively, if there are ways we could put sensors in our own buildings and have these dashboards for our own buildings to also facilitate such conversations.
I jump in and say, I'm not going to volunteer them, but the facilities management folks in our building automation systems do have a fair number of sensors in buildings that are used to operate the various control systems. But there is a bit of management and upkeep to make sure that the data being presented is where it needs to be for that type of public engagement. And so there's probably a resource challenge on their end to pull that off on a larger scale. So, but there is opportunity to pull from some lower hanging fruit there.
Can I add one thing, or is there not time?
Sure, while Mike's starting screen share, go ahead, Nick.
To follow up, I'm curious if they're looking into the business side of the sensors and the data, because it would be really interesting for I teach sustainable business, to be able to tell students there's an opportunity here to start small businesses or do consulting around helping companies to install these kinds of sensors. And then here are the benefits for the companies. Is that being looked into for the greenhouses at all?
One real opportunity, I think, is helping potential farmers understand how to visualize and interpret data that they might be able to obtain from some cheaper sensing systems and things. And so there are some different opportunities there that'd be worth discussing.
Yeah, it's a great question, Nick, and it really depends on so many variables, what they're growing, how strict their climate control is. So yeah, it'd be a great business question. Absolutely, yeah, and we're working with Series Greenhouse Solutions in that regard as well, and they're in the business of selling these systems, but I think we do have a good partner, and they've actually put us in contact with some other universities that are looking at similar questions. But I'd be happy to speak with you more on that.
Yeah, I'm going to chime in here. Sorry to take the mic, Jeremy and Andrew. Nice job. But Jeremy, I'll put you on the spot. There are some dashboards that are currently visualizing this data, right? And would you be willing to share access to
Oh yeah, absolutely. Yeah, there's public access. It's week worth of data. I'm happy to share that. I can even put that in the chat if people are interested.
Yeah, and for those that joined a little late, we will have some time. Some of the speakers can stay on after. If we can have some extended conversation about this too, please do stay on if you can. And I'll go ahead and let Mike get started. He's presenting the title here, Manure Management and Nutrient Flows on a Small Farm. And this is part of the STEPS AppState effort. Go ahead, Mike. Thanks.
Okay, thanks, Grace. And thanks all for being here today. It's great seeing so many familiar faces. Jeremy, on your end, I will note, in July, I got to tour that greenhouse and I had no idea how recently constructed it was. I knew it was gorgeous, but it really is gorgeous. So anyone who has a chance to tour it, I encourage that. It's a really nice facility. All right, so what I'm going to talk to you guys about today is manure management on a small farm, and specifically my farm. So this is an attempt to tie my home life in with my academic life, which is a nice direction I've gone. So this animal here is named Ladybug, and she was our first dairy cow. We now have a second, and that's always a pleasure to get to do things that tie into what you love. And so, as Grace noted, this is part of the STEPS Center. And to give a brief background, that's a National Science Foundation Science and Technology Center that Christine brought to campus. And it is a huge organizational nightmare might be the right way to say it, but it is a very large effort spanning 11 plus institutions. There is, I think, closer to 180 researchers actively involved these days. Christine is our integration director who helps to coordinate operations across so many researchers and keep us moving effectively together. And so the notion of STEPS is to look across length scales from, sub-nanometer atomic level scales out to regional and global scales, and look at technologies that can be harnessed to address phosphorus sustainability. And to give just a brief background on that, because this really was not something I was intimately familiar with before I became tied in with this project. Phosphorus is obviously essential for agriculture. It's predominantly, by which I mean 90+% of the phosphorus going into fertilizer is mined from phosphate minerals in moderately geographically constrained areas. And that sets up sort of two challenges, which on the one hand, you have a resource scarcity. There's not enough phosphate mineral to go around, and there's potential that as demands for agricultural production this century increase, that we may run out of mine phosphate by the end of the century. And at the same time, you then have an environmental overabundance of phosphorus as it runs off into surface waters and leads to eutrophication. And so the grand vision for STEPS is this 25 and 25 vision, which is to say, can we have a 25% reduction in mined phosphate and equivalently a 25% reduction in runoff from agriculture within the next 25 years. And so to achieve that, the STEPS project, again, is focused on things ranging from sorbent materials at the atomic scale, what's going to bind phosphate and allow it to be recovered from surface waters and returned to the fields. And then on the far end, how do we integrate such technologies into agricultural practices and then use that information to inform, national and global scale policies. So there's really a very broad collaborative effort to integrate these disparate directions and come up with a solution to phosphorus sustainability. Within that project, often there's reference to a phosphorus flow diagram, which is shown here on the right. And the key things to emphasize is, again, that agriculture is very central to the story of phosphorus, that what we're looking at is fertilizer production, and somewhere around roughly a third, a quarter of the phosphorus applied to fields ends up in surface waters. And so trying to sort of close this loop and keep phosphorus within the boundaries of the global food system feeding back into itself rather than this one pass mined phosphate mineral out to surface water. The more we can close that phosphorus loop, the better we can manage future phosphorus demands. So in that regard, the goals of the particular project I've initiated here at AppState is to quantify phosphorus fluxes through a small dairy farm, which again is at my house. So we're working to look at how phosphorus is flowing into and out of our farm. And then we're hoping to use those results more broadly to infer phosphorus flows through livestock operations across the high country. So looking at dairies, and especially we'll need to extrapolate that to beef cattle as we consider how cow operations across the high country are impacting regional phosphorus flows. And then a project that ties in with work I've done in the past and that I have a fair bit of interest in is how can we use anaerobic digestion to both manage manure on the farm and then to help retain phosphorus so that it can be recycled back to fields. And so that's a mixture of then mapping the phosphorus flows that exist on the farm and modifying them through improved manure management are the goals of this project. So to introduce the study site, this is my house just for reference. Here are the barns out here. But we 7.5 years ago, bought the property, a little bit longer than that actually, but 7.5 years ago, we moved the animals out here. And at the time we fenced it such that we essentially were grazing 2 fields and the rest of the property was hay. And then over time, we factored in like another couple acres down here, more of grazing. So we have 4 distinct areas and we have reasonable records of what animals lived in what field at what time of year for the past 7 years. So I came at this just by happenstance, having a kind of a fun record of grazing intensity across different pastures over the last several years. And we're talking very low stocking densities, 1 or 2 cows and 5 to 7 goats. So about, equivalent of 3 or 4 animals at most. And the individual fields are, half an acre up to 4 acres. And so what we started this summer was we brought a group of summer venture high school students pictured at right. I had them for a month and we brought them out to the house and spent a couple of days digging up soil samples on a 20 by 20 meter grid across the field. And then these we took, removed the organic layer and tried to get sort of at the top of the topsoil. So the A horizon of soil about 8 centimeters deep is what we sampled. And once we dried the samples, we then looked at 4 or 5 different measurement techniques. And since the STEPS project is focused on phosphorus, the main thing we focused on would be phosphate versus total phosphorus. And to explain that, and I don't really have a slide on this, but orthophosphate is your traditional inorganic PO4 phosphate anion. And there's a whole range of phosphorus speciation. Much of it is phosphorus 5, such as in phosphate, but you have other oxidation states. You definitely have other protonation states. You have phosphate tied up in various organic forms. And so rather than measuring orthophosphate, an alternate approach is total phosphorus, where basically you take your sample and rather than extracting out soluble phosphate in dilute acid for total phosphorus, you would instead boil it in concentrated nitric acid. And so doing, essentially everything oxidizes to phosphorus 5 oxidation state and everything hydrolyzes to phosphate. So it's a way to take all the phosphorus in the sample and convert it to a single form. And so those measurements were done, and I'll get to how we measure the phosphate on the next slide. But at the same time, we wanted to look at other nutrients. So we looked at soil carbon by combustion analysis, which is available in the chemistry department. And we looked at nitrate and pH using ion selective electrodes, just to sort of get a more well-rounded picture of soil health at the field. For our colorimetric detection, this is an old school method. This phosphorus detection methodology comes out of the 1960s. The standard method was written in the late 1970s. What I like about that is it's low cost and it's relatively fast. What I don't like about that is you have a lot more wet laboratory dilutions and processing steps to get to where you have meaningful data. But what we're doing is a molybdenum blue assay. So essentially we mix a aqueous water sample, which could well be an acid digested soil sample, but we mix our solution with molybdenum, a little bit of antimony, and what that does then is that the molybdenum binds phosphate and forms this 12 molybdenum ion cluster. And when you add ascorbic acid to that, which is vitamin C, the ascorbic acid's a reductant. It adds an electron into one molybdenum, and it makes this molybdenum 5,6 charge transfer band, which is this brilliant blue color you see here. And the concentration of the blue color is entirely proportional to the amount of phosphate present, since phosphate's bridging the molybdenum clusters together. So with that, I'm going to speed up for time. What we're looking at then is a single absorbance. We get a nice, relatively linear absorption calibration curve. What I like about this is I was doing the same assay 10 years ago, and I can superimpose the 2 calibration curves from a decade apart, and they overlay perfectly. It's a very robust measurement. Our quality control specs come out good, that we measure quite well, although I do regret this has a fairly limited dynamic range, which means our sensitivity on concentrated samples is limited because we have to dilute so much and then multiply that error through. What we found was that essentially for extractable orthophosphate, there's a very high correlation between phosphate in the topsoil and the amount of grazing intensity. The x-axis here is an animal unit month per acre. So essentially 1 cow is an animal unit, and the feed needed to feed that cow for a month is an animal unit month. So this is essentially averaged out as cows per acre over the 7 years of the study period. 5 goats would be equivalent to 1 cow in terms of feed consumption. So as you can see, there's a nice tight correlation. We have, tie-in between phosphate available from grazing intensity. When we look beyond phosphate to total phosphorus, we see much weaker correlation, essentially none, no statistical difference within these 4 samples. And that's probably mainly due to the creek. And I think what we have going on is deposition of soil phosphate minerals coming down from upstream and depositing during flood events, such that we have a lot of inorganic phosphorus present at the creek site. When you look at the speciation and say what percentage of the phosphorus in the pool is actually phosphate, you see a very, very tight correlation. And I think we can say that animals are depositing phosphate, which is the bioavailable, accessible to plant form of phosphorus. Looking further, soil carbon does correlate with grazing, pH and nitrate don't. And one of the key things I'm looking at with nitrate is this outgroup, considering nitrate has very high solubility and probably washes out of the soil on a much shorter time scale than 7 years. So that looking at long-term accumulation, low solubility phosphate probably does follow long-term grazing patterns, whereas highly soluble things such as protons and nitrate do not. So where we're going with this, we're looking to continue measurements. In particular, we're just now halfway through measuring the phosphorus inputs to this site. So what we've been doing for most of a decade is taking hay out of this field and thereby growing phosphorus, pulling it over to the other side and feeding it out to animals in these fields. And so understanding how much phosphorus has been transferred from the hay field to the pastures by phosphate content of the hay, looking at how much we've exported through milk sales, so measure phosphorus content of the milk we're producing, and then look at what's coming upstream and downstream in the creek to see if there's runoff we can detect across this just few acre site. And so with that, we're trying to map phosphorus flows through the farm and then hopefully use that more as a proxy to look broadly across the high country at how does animal husbandry practices influence phosphorus flows in the high country. Last second, I know I'm over, so thank you for the extra minute, Grace. The last thing we're doing, and this is largely just now getting in progress, and we'll be having results coming in through the spring, but we're using anaerobic digestion, and this is a very standard manure management technique where you feed manure in, nutrients tend to collect more in the sediment. Over time, larger scale protists and some aerobic bacteria will break down biomacromolecules into monomers and organic acids that then get fermented into biogas, which is predominantly methane and CO2. And if you feed this in a little bit of manure every day, effluent comes out every day, and you can collect methane and use that for energy. So the question then is, how does the feeding rate impact phosphorus partitioning between the effluent that's normally leached out to a field versus the sediment that could be collected and then spread as fertilizer at a later time? And how can co-additives be used to enhance phosphorus recovery? So what we've started now is we have 3 sets of duplicate digesters running with different retention times. And we're hoping to get through some runs through the spring and then start looking at co-additives as well for the anaerobic digestion to retain nutrients. And so with that, I just want to thank you guys for your attention. Jillian and Sabella are the 2 students who did the vast majority of the work here, along with the Summer Venture High School students. And thank you so much for your time.
Thank you, Mike. That's really interesting. We do have time for a question as we exchange presenters here, but if you don't mind to stop sharing, and I'll invite Liz to bring her slides up. And in the meantime, if there was a question for Mike, we could address that quickly while Liz is sharing her screen. Okay. That is pretty instrumented little farm you have there, it looks like.
Pictures can be deceiving.
Okay. Liz, I can see your presentation. I can't yet hear you. Oh, go ahead, Lakshmi.
Yeah, I'm sorry. Can I ask a quick question? I was having some issues with my microphone here. This is wonderful. I'm sorry, I could only start with the second presentation today because of the advisory board meeting we had. But one of the, I run some summer STEM outreach programs. And in fact, we did visit the Blue Ridge Women in Agriculture this past summer, which was really, oh, sorry, there's, hold on, let me get my door. I'm sorry.
get out of here. Okay, sounds good.
I'm so sorry, we have an event and there's a lot of people talking. So I was going to ask, would it be possible to bring students for a visit to the farm and learn more about what you're doing?
Yeah, sure. If you, I mean, we love showing off what we're doing, so we'd be happy to do that if you'd like.
Oh, wonderful.
We can also, and I'm sure Liz can as well, connect you with a whole bunch of people working at larger scale too. So there's, I think, a lot of options to do that for sure.
Part of that summer camp experience is for students to work on some real world projects. So part of it is to look at how technology is helping in the agriculture sector. I mean, the whole thing is surrounding sustainability, but especially like smart agriculture and whatnot. So I would love to probably touch base with you later, Mike.
That sounds great. I'd love that.
Thank you. Thank you.
Cool. I love hearing those connections being made. Okay, I'll turn it over to Liz Whiteman with Blue Ridge Women in Agriculture. Thanks, Liz.
Thank you, Grace. Can y'all hear me?
Yes.
All right, awesome. So as Grace mentioned, I'm the Executive Director for Blue Ridge Women in Agriculture. We operate the High Country Food Hub, which is an online marketplace that features over 100 producers from within 100 miles of Boone. Here's a brief overview and just a little bit about the history of Blue Ridge Women in Agriculture. We were founded nearly 20 years ago by a group of female growers who were hearing that women can't be farmers and were being kept away from resources. They knew that they could be farmers because their mothers and grandmothers had grown food for their communities. So they started collaborating on each other's farms and teaching each other what a just local food system looked like. Since our founding, our programs have grown to support the needs of our local food system and community. Our current work and goals are to increase the demand for local food through the expansion of markets, including the food hub and farmers markets. We work to ensure equitable access to local food through our Double Up Food Bucks program and the Local Food as Medicine program. And we work to support producers through our Blue Ridge Craft program as well. So what I'm going to talk about today is the High Country Food Hub and the origin stories and how we got to where we are today. So the origin story of the High Country Food Hub really revolves around addressing challenges that producers in our community face. So some of the challenges that we were trying to address at the inception of the hub were that farmers and producers in our area were facing barriers to accessing funding for infrastructure that was needed to grow their businesses and expand their market options. For example, livestock farmers might have limited freezer storage on their farm, which meant that they could only access and process a limited number of animals at a time. There were stories about farms that had 18 chest freezers on their farms just so that they could store the animals that had been processed in one trip to a processing plant that was located off the mountain. And even with a pretty robust local food system here in Boone, with a lot of local farmers markets and access to CSAs, only a small percentage of the population was buying local food and value-added products directly from local farmers. The farmers markets don't always fit consumer schedules, and they aren't always ready to commit to purchasing an entire CSA share for a whole growing season. So the High Country Food Hub began to develop. When a space opened up in the Agricultural Conference Center building, Carol Coulter, who was one of our founders and our executive director at the time, saw an opportunity to meet some of these challenges, and the High Country Food Hub was created with support from the Cooperative Extension, county commissioners, and the town of Boone, along with a number of grant funds for startup costs. At the very beginning, the food hub comprised of one walk-in cooler and one walk-in freezer. The freezer shelves were rented to farms. You can see a photo here of what that looks like, so that they could store their products. And as those freezers and coolers quickly filled with products from local farms, BRWIA staff began to look for ways to help farmers gain access to more consumers. At the time, the Watauga County Farmers Market was extremely competitive to get into. There were 17 new producers that were turned away in 1 year. And the idea of an online marketplace was born. So this is what the High Country Food Hub website looks like to a consumer when they navigate to our website. We use a software called Local Food Marketplace to run our online market. And I am going to try to play this video to show how the Food Hub works from a retail perspective.
Liz, it just occurred to me that if there was audio with this, it's not coming through to us. I should have maybe said something earlier, but it's certainly informative even without audio if there's some there.
So thanks to our partners, GeoCore and Resourceful Communities for producing that video for us. And now I'm going to talk a little bit about what it took to get to that shiny product that you just saw. So there was a whole lot of problem solving that was involved in the Food Hub from the inception. We basically have created all of the infrastructure that we needed. You can see here that we utilize a lot of bins, a lot of shelves. This is a photo of one of the inventory sheets for a farm that stores product at the Food Hub. We've learned a lot about policies and procedures for how to efficiently store and aggregate and organize and deliver products from over 100 producers to distribute them to approximately 300 customers per week on a weekly basis throughout the year. This is a graph of our weekly sales comparison over since 2019. And as you can see, the green lines here on the graph represent 2020 sales. And the orange lines and green down below demonstrate the 2019 numbers. So we experienced really massive and sudden growth in 2020 as a result of the COVID-19 pandemic. And you can see from the blue lines that interest in local food remains significantly higher in 2022 than it was in 2019. That's something we're really proud of and something we're working on a daily basis to maintain in this community. These are just some photos for comparison. The top two photos show you what the Food Hub looked like for much of its existence up until 2020. We stored customer orders in one small walk-in cooler, and then overnight we saw our customer numbers and our sales increase by many times. And we were fortunate to receive a donation from Cisco of a refrigerated trailer that we were able to use for a couple months, and we're able to store many more orders as a result. We also have pivoted in a lot of ways over the past 3 years. I saw a lot of familiar customer names who are logged into this webinar. So y'all have been on this journey with us, but as a COVID response, we moved pickup outside. That was initially to protect public health and safety. And since then, we have moved to a text to pickup system so that folks aren't standing in a line around the building up to King Street waiting for their orders. We also have seen that our customers are very loyal. About a third of the Food Hub's customers order every week. And we've also seen that nearly half of the customers that are currently registered in our entire system were added in 2020. Just a little bit of discussion of what it took us to get here. We have been extremely fortunate to have the support of a really wide range of folks from across our community. As I mentioned, Cisco donated a refrigerated trailer for much of 2020. The Dr. Pepper bottling plant lent us some glass door coolers. Appalachian State Campus Dining lent us their rolling carts when campus dining was shut down for about a year. And Cooperative Extension lets us use their space for free, which is the reason, a large reason why our market channel exists. In terms of infrastructure, since that Cisco trailer was in our parking lot, we've been able to add 2 more walk-in coolers. Our most recent one was turned on last winter. You can see a photo of it there in the middle. That was thanks to a grant from the Golden Leaf Foundation. And then finally, it took a whole lot of patience to get to where we are today. So I am going to show this graphic again because I think it really illustrates the first years of the hub compared to now. We were fortunate to have the systems in place in early 2020 so that when restaurants shut down and farmers were really facing existential crises and they needed to shift to a different market channel really quickly, we could handle that transition seamlessly. This is an old photo of the last time that we had all of our producers gathered together in early 2020. The group of producers is probably twice that size by now. But we recently hit a really amazing milestone where we have seen $2.7 million of sales through the High Country Food Hub since it began in 2017. And that means that over $2.2 million went directly back to producers. 84 cents of every dollar that's spent at the High Country Food Hub goes right back to producers. And we recognize that that's money that likely otherwise would have left our community, would have gone to big box stores, grocery stores, and instead it's going to support the unique community that we live in. Another really unique aspect of the Food Hub is that farmers only harvest and deliver what was ordered that week. So it cuts down on waste and allows farmers time to grow and farm and spend less time at farmers markets. So we really see this as an efficient market channel. And finally, what's next for the High Country Food Hub? So as I mentioned, in spring of 2021, we received a Golden Leaf Foundation grant to expand to satellite pickup locations. You can see a photo on the top there of one of our vans that we were able to fund through that grant. We've since been able to open a number of satellite pickup locations in Ashe, Avery, and Watauga counties, which have resulted in over $137,000 in additional revenue for producers. We see that as a really big opportunity and also recognize that transportation and getting to Boone on a weekday during business hours is a really big barrier for a lot of people in our community. So we're looking forward to continuing to expand the satellite program and reach more of our community, as well as increase the capacity of High Country farmers. Grace, that is what I have. So I'm going to stop sharing my screen.
Yeah, thank you, Liz. It's really neat to see that all in one place, the years of evolution. We do, for purposes of recording, we do try to close these, but I want to remind at the hour, but I want to remind people that we do have a few speakers that can stay on afterward for some extended discussion. But I think we could go ahead and take a question, or Christine, would you prefer to do the close now? I guess. Maybe
I say let's let Liz field a question with the way that you manage this time so perfectly. We could do that before we close. Well, selfishly, I have a question, and I feel like I should know this because, you know, Grace has put in so many years with BRWIA as well, and we have other folks, but do other people copy you? It seems like everyone should do this. Is there a generalizable model? It makes so much sense and it's really impressive. I'm curious about other folks and if it's transferable to other communities.
Yeah, that's a great question. So when the food hub was kind of being conceptualized, we did not find that there were a lot of food hubs that existed that function in this way. A lot of food hubs tend to focus on wholesale and aggregate similar products from a bunch of different farms and then sell to larger corporations and things like that. But we spend a lot of our time talking to people who are thinking about opening food hubs in their communities. And we're really hopeful that it's an idea that's transferable. It definitely, as you can see, like this food hub was formed with like our community in mind. And we know that a food hub is going to look different in every community, especially in communities that don't have such great access to small scale diversified vegetable and livestock farms like we have. But we hope that we serve as an inspiration and also that we can give good guidance to other folks that are interested in doing the same.
I'm curious, Liz, if you get questions sometimes from producers, or you have any feel for demand for help with the kinds of things that Andrew, Jeremy, and or Mike are researching.
Yeah, we definitely, particularly what Jeremy spoke about with more efficient greenhouses, we are always trying to talk producers into growing year round, because we definitely see that the demand for food doesn't drop in the winter and that our climate is more challenging to grow in the winter, but it's certainly not impossible. We would definitely be interested in connecting with y'all and hosting some workshops so y'all could talk to farmers about what went into those greenhouses.
Well, I love how perfect of a kind of a landing spot that gives us, because one of the big things we hope comes out of these is, you know, we keep dropping the Google form link in, is figuring out what would be useful or beneficial, helpful conversations we could help host. We don't have to be part of it if hopefully connections happen and things go on from here, but there's been at least 3 or 4 concrete ideas that you all have brought to the table of cross-pollination and different ways that we might work together. So please feel free to reach out to us either through that form or just email us if there are ways you'd like to connect and pursue different questions down the road. So that's what we're here for. Thank you so much for joining. And we'll put some things in the chat about how you can join our Google group and get all the messages of different events that we might have. And we look forward to seeing you again next time.